Lesson 3.5 we're splitting into two parts, and we're actually going to do the last examples in the lesson today first, because they're a little bit easier to deal with and they look a little more like what you're already used to. So these are called compound inequalities, and there are two types. Today we're going to talk about the OR type, and then tomorrow we're going to talk about the AND type. And they're set up a little bit different, so there's things you have to learn specifically to each of them. The OR type of inequality basically means either or. So it can be one answer or the other. It doesn't have to be the same for each of them. So your solutions don't have to be the same. And you'll see what I mean once we get going with that. So we're actually going to start on example 4, if you were looking at your book. And I'm going to go ahead and write it that way so that you see it. And what I want you to do is write an inequality and then graph it. And the inequality is all real numbers that are less than -3 or greater than 7. So when you go through to write inequalities for these, you want to look for keywords. Less than -3, or is a keyword because it tells what kind you're going to set up. Greater than 7. And the word or is going to tell you that you're just setting up two separate inequalities. One that shows less than -3 and one that shows greater than 7. So I'm going to set this up just like I have been in the past. A number, I can call it x, is something to -3, and it said it's less than -3. And then I'm going to use the word or. A number is greater than 7. And you're done setting that up. So that's all you're going to do with these OR compound inequalities. Now you're just going to graph each of these on one graph. So you've already been graphing individual ones, now you're just going to have two on one graph. I notice some of you are putting your dots right at the edges where you don't have any space. Try to make sure you leave a little bit of space on the numbers that you're going to be putting the dots on. So now I'm going to have an open dot because it's not or equal to on -3, and I'm going to shade everything that's less than -3. So if I picked a number like -5, -5 is less than -3. So all of these are my possible answers. Then I'm going to graph the other one. X is greater than 7, so I start at 7, open dot. I'm looking for numbers that are greater than 7, like 9. 9 is greater than 7. So these are all my shaded answers for that. Notice the graph opens opposite directions, and that's going to happen with these all the time. That's the pattern that they fit. So it just opens opposite directions. And this compound inequality can have all of these answers or all of those because it works for one of them. It doesn't have to work for both. So go ahead and add over here that the graph opens in opposite directions. So you want to remember that for the OR inequalities. The middle is not shaded. Go ahead and write this example down. This is an example with real life application. So discounted fares are available to children 12 and under or to adults at least 60 years of age. If we were talking equal, then we were talking about only children that were 12 and only people that were 60. But we're talking about a variety of ages, so that makes it an inequality. All right, if you're not done writing that down, hit pause. Otherwise, we're going to continue. So what you need to do when you come across these, same idea. Go through and look for important information. Discounted fares are available to children 12 and under, and then that key word or means we have a compound inequality, to adults at least 60 years of age. What this means, discounted fares is basically your variable. So you could say D equals discounted fares. And now you're going to set this up exactly like you've been setting up your single ones. So 12 is going to have some relationship to discounted fares, and 60 is going to have some relationship. So I have discounted fare with something to the number 12. I'm going to use the word or, discounted fare with something to the number 60. And then I'm going to go back and fill in my inequalities. So are my discounted fares going to go to ages that are greater than 12 or ages that are less than 12? And since it's 12 or under, it should be less than. And because it can be 12, it's available to children 12 and under, it's an or equal to. 12-year-olds can get the discount. Then I go look at 60, and it says at least 60. Remember that word at least doesn't mean less than. It means 60 is the least it can be. So all of these ages actually need to be greater than 60, but it can be equal. So it's basically setting up exactly what you've been doing, but for two different sets of information at one time. And then you're going to go graph it. So I'm going to have a closed dot at 12, since it's or equal to, which would be right about there. And everything that's less than 12, 10, 0. The only thing is I'm going to stop at 0 in this case because real life says we're not going to have a discounted fare to someone in a negative age there. So really it's only from 0 up. Then I'm going to have a closed dot at 60. And again, it's all the ages that are greater than 60. So 80 is greater than or equal to 60, all of these. And it follows that same pattern where it opens opposite. But you should always check to make sure that numbers in there make sense, because then you know you set that up correctly. So you might want to make yourself a little note here. Stopped at 0. Because of age. So it's a real life application. You always need to think about real life application if something like a negative even makes sense. Example 5 asks you to solve and graph. So before we were just setting them up and looking at them, now they're actually going to give you one to solve and graph. And the example says 4x plus 3 is less than negative 5, or negative 2x plus 7 is less than 1. And again, this is just like what I was talking about a minute ago. You have two separate inequalities, so you're just going to solve this one, and then you're going to solve this one. And you're going to solve them exactly like we already have been in class. So we're trying to isolate the variable here, draw our line, And then we're just going to follow those same steps. I'm going to go ahead and subtract 3 from both sides. I end up with 4x is less than a negative 8. Remember, you add those negatives. And then I'm going to isolate x by dividing by 4. And I end up with x is less than negative 2. I didn't flip my sign, even though I had a negative over here, because a negative didn't go across. It's the only time you flip it. So that's the first answer. Then I'm going to bring down the word or, and I'm going to go ahead and solve the second one. Same thing. Isolate that variable. So you would go ahead and subtract 7 from both sides. You end up with a negative 2x is less than a negative 6. Divide by a negative 2, and when you divide by a negative, go flip your inequality around right away so you don't forget. This becomes a 1. Bring down my x. Negative divided by a negative is a positive. 6 divided by 2 is 3. And that's my answer. X is less than negative 2, or x is greater than 3. And then I would go graph it. And when I go to graph it, no closed dots, open dots only on both of them. So I have a dot on negative 2. All my x values have to be less than negative 2. So if I tried something like 0, 0 is not less than negative 2. So this side doesn't work, has to be that side. So that's my shaded side. And now I'm going to graph the other one. Dot at 3, open because it's not or equal to. And x's have to be greater than 3. So these numbers are all greater than 3. And it follows that same pattern. Go ahead and write this down. So when you're solving these, you're just going to solve each individually like we have been in this chapter anyway, and then you're just going to graph on one graph. So nothing new today really, you're just applying what you've already learned to the word or and having 2 of them to deal with at the same time. Tomorrow's is going to be a little bit different, so you want to make sure you really pay attention to the differences between the or and the and compound inequalities. And then after that, we're going to talk about absolute value inequalities, and that ties directly into using the and or the or inequalities. So it can get a little confusing if you don't spend some time really looking at the differences.